Alright, so we are continuing on in Algebra 1. So we're going to start with a quick warm-up. So simplify each of the following: square root 16, square root 169. So take a second and simplify each of the following. Alright, and when we do square roots, what we're doing is that we're looking for two numbers that multiplied get you the exact same number. These two end up being what are called perfect squares. So the square root of 16 ends up being 4, plus or minus 4. So plus or minus 4. Because if you multiply 4 times 4, you get 16, and if you multiply negative 4 times negative 4, you get 16. And for the square root of 169, you get plus or minus 13. Okay, so you end up with plus or minus 13 on that one, because again, 13 times 13 or negative 13 times negative 13 gets you 169. Okay, so that's the perfect squares, but now we're going to be looking at it, what if they're not perfect squares? And these square roots are called radicals because they're not just square roots. Sometimes you have cubics and fourth roots and so on and so forth. So section 1 we're looking at here, we're simplifying radicals. Okay, so simplifying a non-perfect squares. Okay. And so what we're going to do here is we are going to take our number, whatever it is, in this case 72, and we want to break it down into its factors. Okay, so you could do a factor tree with this, and like that. So 72 can be broken down to 8 and 9, and what we want to do is we want to break it down so it's only prime numbers. So your prime numbers are numbers that can only be multiplied to get is 1 in itself. So 2, 3, 5, 7, 11. Those are all perfect squares, or prime numbers, because you can't get 2 unless you're going 2 times 1. And so 8 and 9, those are not prime, so we have to break those down as well. 9 breaks down to 3 and 3, which are perfect squares, or not perfect squares, are prime numbers. And so since they are prime numbers, we're done with the 9 side, but the 8 breaks down to 2 and 4. 2 is prime, but 4 is not, so we have to break it down again, giving us 2 times 2 times 2 times 3 times 3. So if we factor our number all the way down to prime numbers, we should be able to multiply all of them together and get back to the original. So 2 times 2 times 2 times 3 times 3 gets us back to 72. Okay, so that'd be a way to check to make sure you got it right, is if you list out your prime numbers, if you multiply them through, you should get them back to the original. Now, when we're dealing with these, what we're looking for is, since it's a square root, we're looking for pairs. So we're going to be looking for the pairs or the couples. Okay. And with this, you can think of the radical like a house. The couples exit the house. You know, they exit, they go on dates, while the single stays home. So anything that's by itself has to stay inside the house. And so when those two come out, you're left with 2 times 3 square root of 2. You multiply 2 times 3, which gets you your answer of 6 square root 2. And that would be the simplified version. Okay, so that would be simplified of this. Now, if you are unsure if the answer is correct, you just take this number, you take the square, you multiply it through 6 times the square root of 2, and then you take this number, and you take the square root of it, and they should end up with approximately the exact same. Okay, depending on how far you take, if you reduce anyway, if you do like square root 2, reduce it down to 1.414, and then multiply by 6, you're going to have a little bit of error. But if you type both of them straight into the calculator, they should be the exact same number, and that shows you that it's the right answer. Okay, so take a second to simplify each of these. Okay, so simplify them so you should have a number on the outside and a number on the inside if they can be broken down. If nothing comes out, then it stays as is. Okay, so take a second and simplify each of the following. Alright, so with the first one, when we end up simplifying it all the way down, we get 3 square root 7. And that's because when we do 63, that breaks down to 9 and 3, or 9 and 7. 9 and 7, and then 3, 3. So we end up with the square root of 3, 3, 7. The 3's exit, but the 7 stays home. Okay. So now 122, if you break 122 in half, you get 2 and 61. Okay. Now you got to go, okay, what two numbers multiplied together get you a 61? And none of them do. So 61 is a prime number. And so what happens is that you're left with just the original. So if they don't break down and you don't get any pairs, you're just back at the original. Okay, so it's back at the square root of 122. Okay. Now if you're looking at something that was a cube root, you're looking for groups of 3. Okay, so simplifying with variables, exact same process. So the coefficient, the number out front, you do the same thing. So 18, which you can break down to 6 and 3. 6 is 3 and 3. So we're left with the square root of 2 times 3 times, it should be 3 times 3. Oh yeah, 2 times 3, because this is a 2. 2 times 3 times 3. And then with whatever the variable is, you want to write out whatever the exponent is, that's how many variables you have. So in this case, x to the fifth would be x times x times x times x times x. So it's 5 1. And then again, what you're looking for is you're looking for pairs. We have a pair of 3's, so they go out of the house. We have a pair of x's, they go out of the house. We have another pair of x's that we can make, and they go out of the house. And the 1x stays in, and the 1, 2 stays in. So we're left with 3 times x gets us 3x squared, and then 2x is left on the inside. And this would end up being our answer. Okay. Okay, so now this one, we have a number already on the outside, and then we still want to do the breakdown. So the number on the outside we don't worry about until we start taking numbers out. So we just focus on the inside, so we look at 20. So 20. 20 can be broken down into what factors? It can be broken down into 4 and 5. This is 2 and 2. So it looks like we have 2, 2, 5. Okay. And then we have 3 x's and then 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. And all of that is underneath the radical. We're looking for our pairs. And all of our pairs exit as 1, so this group of 2's exit as 1, 2, this group of x's at 1, and then you have 4 y's. Okay, so again, seeing it written out here, those 2's exit, the x's exit, this y, this y, this y, this y. And so if you have variables that repeat, what you do is you basically count how many groups of 2 can you make. So in this case, these y's, you can make 4 groups of 2. Ending up with our answer, once we've taken everything out, we just multiply everything together. So 2 times 3 is 6, x, and then we have 4 y's, so it'd be y to the 4th, square root of 5x would end up being our answer. Okay. So if there's a number out front, you just multiply it into it. Okay, so what about if you have fractions? Now, if you have fractions, what ends up happening is that we have to do something called rationalizing the denominator. We do not want square roots in the denominator. Okay, we want to be able to move those square roots to the top. And so what we have to do is that we have to take our fraction and we are going to multiply it by whatever the square root of the denominator is. So the square root of the denominator, and the first one, is the square root of 9. So what we could do is we could just simplify it to start. Okay, so this one we actually could just simplify. What's the square root of 9? Square root of 9 is 3. So we're left with just 2 over 3. Okay, but the second one, we can't simplify the square root of 3. And so when we end up simplifying it, we end up getting 4 square root 3 over 3. Okay. And again, like what I said about a minute ago, that's called rationalizing the denominator, which we do not want the denominator in the, or radical in the denominator. And so what we're going to do is that we're going to multiply the top and bottom by whatever the square root of the bottom is. So in this case, square root 3. Now, when you multiply the top, you're just left with 4 times the square root 3, which is fine. The bottom, though, when you take a square root of 3 times a square root of 3, that ends up getting rid of the square root. Okay, so when you take a square root and multiply it by itself, or squaring a square root, and you're left with whatever's just stuck on the inside of that radical. So when you take a square root 3 and multiply it by square root 3, you end up with just 3. If you take the square root of 18 times the square root of 18, you're left with just 18. If you take the square root of 100 times the square root of 100, you're left with just 100. Okay, so that's what you do when you're rationalizing the denominator. Okay, so the next one here, what we have is that we have a square root with a whole fraction. And when you have a square root of a whole fraction, what ends up happening is that you can break it up into two separate fractions, square root of 8 over square root of 27. Okay. Now, there's a couple different ways you could do this. One way would be to simplify 27 first and then rationalize it, or you can just rationalize it straight away. Okay. So in this case, what I've done is I've just taken the primes of each. Okay, and I'm simplifying each one. So if you look at the first one, you take 2 out. Second one, you take a 3 out. So you're left with 2 root 2 over 3 root 3. Now you got to rationalize the denominator. So to rationalize this denominator, you're just going to multiply it by the square root of 3. You don't have to worry about the coefficient out front. You multiply it by the square root of 3. So when you multiply the bottom by the square root of 3, you'll just left with 3 times 3. When you multiply the top, you're going to multiply those square roots together. So you're left with 2 times the square root of 6 over 3 times the square root of 9, which this reduces down to 3 times 3. And the top ends up being 2 square root 6 all over 9. That ends up being your answer. So that's rationalize the denominator. If you're taking the square root of a fraction, you can break it up so you have the fraction of the radical on top and the radical on bottom. Okay, and then doing the square root. Okay, so that's the end of section 1. Your homework is section 1. Okay, dealing with simplifying these different radicals.